Dr. Minde, and I'd like to finalize on the organs. And we were in the previous lecture we were discussing the eyeball, and we talked to the outer sclera and cornea, followed by the choroid layer, of choroid, ciliary, and then the innermost layer is. So the cell bodies of the rods and cones are in the plexiform layer. So plexiform layer synapsing occurs. Okay, then you get to the inner plexiform layer again, where more synapsing occurs before you get to the ganglion cell layers containing nerves carrying now the ganglion cells that are carrying the visual information into the optic nerve fibers to the inner limiting membrane. So those are the layers of the have your pigment cell layer, followed by photoreceptors, then the outer, the followed by optic nerve, and the inner limit membrane. So basically of the retina. So if you're to see, that's the pigmented cell layer, followed by cones, then you get to the external limiting membrane before you get to the cell bodies of rods and cones, then the external plexiform, then you have your bipolar neurons in a plexiform where bipolar are now synapsing with the ganglion cells, and from the ganglion cells you have the optic nerve, above it the internal limiting membrane. So which nerves are in the retina? We have the photoreceptor cells, which are the receptors that are going to synapse with horizontal cells and also pass the information to bipolar cells. So photoreceptors pass information to bipolar cells. Bipolar cells synapse with ganglion cells. So those are the three major neurons that are carrying the information. But you also have support cells in the retina. So horizontal cells, mular cells, amacrine cells, these are support cells basically. So again, pigment cell layer, rods and cones, external limiting layer. Before you get to external nuclear layer, where you have cell bodies of rods and cones, then external plexiform, internal nuclear layer, where you have cell bodies of bipolar, and then you have your ganglion layers there after the inner plexiform layer. So the rods and cones are there. They'll synapse with bipolar cells, which synapse with ganglion cells. So these spaces that you see are inner, external, and inner plexiform cell layers. So basically that's it. And from the ganglion cells, the optic nerve will carry the information to the brain. So you can appreciate this is how light will come in like this, hit and pass. So light photoreceptor cells, which will synapse with bipolar cells. So the retinal pigment cells contain melanin, so they're pigmented, followed by a layer of rods and cones, okay, which are the photoreceptors. So the outer limiting membrane are just the apical boundaries of the mular cells. Then the outer nuclear layer contains cell bodies of rods and cones. The outer plexiform layer is where rods and cones are synapsing with bipolar cells. But we also have other cells, horizontal and amacrine cells, synapsing with the rods and cones. Inner nucleus layer where you have cell bodies of bipolar neurons, but you also have cell bodies of horizontal, amacrine, and mular cells. Then inner plexiform layer is where you have synapsing between bipolar cells and the ganglion cells, but you also have horizontal and amacrine cells. Then the ganglion cell layer, you have the cell body of ganglion cells. Then the optic nerve before you get to the inner limiting membrane, which is the basal lamina of the mular cells. So the outer portion of the apical boundary of the mular cells is in the external limiting membrane, while by the basal lamina of the mular cells. So the optic nerve comes from the axons from the ganglion cells, okay? Then it will pass through the lamina cribrosa of the sclera. It becomes myelinated, forms optic nerve, and it's usually surrounded by the three meninges, dura, arachnoid, and pia. Therefore, it has subdural and subarachnoid spaces. So the dura actually fuses with the sclera, but the arachnoid and pia, they merge with the choroid within the eyeball. So the optic nerve is just like the brain. It's supported by astrocytes, oligodendrocytes, and microglial cells, which are neuroglial cells of the central nervous system. So basically, that's the histology of the optic nerve. You can arachnoid and pia mater. So this is the nerve, and you can appreciate the fascicles within the nerve separated by connective tissue. So what is blood-retina barrier? Tight junction between the pigment epithelium cells form blood-retina barrier. Tight junction between the pigment epithelial cells form blood-retina barrier. So what forms the refractive media of the eyeball? Light should get to the retina. So you need a transparent cornea. Then you have it passes through the aqueous humor, the lens, and the vitreous humor. So all these form the refractive media of the eyeball. So what are the segments of the eye? The anterior segment is any portion anterior to the lens and is divided into two. An anterior chamber. Anterior chamber is between cornea, iris, and the lens. Okay, so this is the anterior cornea, the iris, and the lens. So this is anterior chamber. Then anything behind the iris but anterior to the lens here, this is the posterior chamber. Okay, so we are saying anterior chamber is between cornea, iris, and lens. Then posterior chamber is between iris, ciliary body, zonular attachment, and the lens. So both chambers contain protein-poor fluid. So aqueous humor has less protein. Aqueous humor, we said, is produced by the ciliary processes as capillary filtrate, and after that it's released into the posterior chamber. It's clear and watery with no protein, and it provides nutrients for the cornea and the lens, which are usually avascular. So what's the flow of aqueous humor? It's produced by ciliary process of ciliary body. Then it will be released into the posterior chamber. Then it will go anteriorly, okay? Ciliary body, process of ciliary body, release into posterior chamber through the pupil, enter the anterior chamber. Then at the corneoscleral junction or at the limbus, you have the canal of Schlemm where reabsorption will take place into the venous circulation. So from ciliary body, ciliary process of ciliary body to posterior chamber to the pupil to the anterior chamber, at the canal of Schlemm, we have a trabecular meshwork that reabsorbs aqueous humor into the venous system. So in cases of raised intraocular pressure, there is no balance between production and reabsorption, and that's what gives you glaucoma. So this is the normal flow: ciliary process, posterior chamber, through the pupil, anterior chamber, then at the trabecular meshwork at the canal of Schlemm, there is a reabsorption. But when there's obstruction at the production place, you get buildup of aqueous humor. So when you have buildup of aqueous humor, you build up pressure, and that's what we are calling glaucoma. And eventually, if the pressure continues for long, it's going to affect the optic nerve, and vision will be impaired. So you can have some clinical aspects. If there's blunt trauma, somebody gives you a blow or you're hit by a hockey stick on the eye, what happens? You bleed within the anterior chamber, and that's what we call hyphema. Then posterior segment. So all that was about anterior segment that's divided into anterior and posterior chamber. Then posterior segment is anything behind the lens, and it's the vitreous space behind the lens and the zonular attachment, and it's around the retinal substance, which is the vitreous body. So the vitreous body is behind the lens in the posterior segment. It's a transparent gel. What are the components of the vitreous body? 99% of it is water, but it contains small amount of collagen and hyaluronic acid. It has few cells which are able to synthesize collagen and hyaluronic acid. So what are the accessory structures of the eye? We have the conjunctiva, the eyelids, and the lacrimal apparatus. Conjunctiva is thin and transparent mucous membrane. Usually, it covers the eye, the cornea anteriorly, so that's the bulbar conjunctiva, and the inner part of the eyelid is also covered by conjunctiva, so that's the palpebral conjunctiva. So we have two parts of conjunctiva: bulbar conjunctiva on the cornea and palpebral conjunctiva on the inner part of the eyelid. Then the conjunctiva has stratified columnar epithelium with goblet cells, and it also has lamina propria and loose connective tissue. So that's the histology of the conjunctiva: stratified columnar epithelium with goblet cells and lamina propria made up of loose connective tissue. So this is the bulbar conjunctiva, and this is the palpebral conjunctiva lining the inner portion of the eyelid. So the eyes have two parts. There's an outer skin cutaneous part and an inner conjunctival part. Then the eyelids have two muscles: orbicularis oculi and levator palpebra superioris. So the cutaneous part has skin, and skin has sweat and sebaceous glands. Then we have eyelashes on the eyelid, and these lashes, they lack the erector pili muscles. Then the cutaneous part also has what we call glands of Moll. What are glands of Moll? Are modified apocrine sweat glands that empty their secretions into the follicles of the eyelashes. Glands of Moll are sweat glands. Then the conjunctival part of the eyelid is lined by palpebral conjunctiva, and it contains large sebaceous glands. Cutaneous part had sweat glands. Conjunctival part has sebaceous glands in dense connective tissue. Then we also have the tarsal plate made up of tarsal glands or the meibomian glands, which are the sebaceous glands. So cutaneous part has glands of Moll's, conjunctival part has meibomian glands, which are sebaceous. So this just explains the histology of the eyelid. So you have the outer cutaneous, that's skin, and the inner conjunctival. So this skin part, you have the glands of Moll, which are modified apocrine, while the conjunctival part has the meibomian glands, which are sebaceous glands. But there's also the presence of the tarsal plate, which is connective tissue. And we have said the eyelid has two muscles, the orbicularis oculi, that will close the eye, and levator palpebra superioris, that will elevate the eye. Then we have the eyelashes at the tip of the eyelid. Okay, so then we move to the lacrimal apparatus of the lacrimal gland that produces tears, and lacrimal glands are tubular alveolar glands. They are at the anterosuperior temporal portion of the orbit, and they produce tears that moisten the cornea and the conjunctiva. They contain lysozymes, and these are able to hydrolyze cell walls of bacteria that enter the eye. The lacrimal apparatus are supplied by ophthalmic vessels. So that's the flow of the lacrimal fluid from lacrimal gland through the ducts into lacrimal lake, from lake into the punctum, from the punctum into the lacrimal sac, from the sac into the canaliculi. Okay, sorry, from the punctum into the canaliculi, from the canaliculi into lacrimal sac, through the nasolacrimal duct into the inferior nasal meatus to enter the nasal cavity. So what's the innervation of the lacrimal gland? Parasympathetic. So you have nervus intermedius or facial. It will pass through geniculate ganglion without synapsing. Then it will give greater petrosal nerve. This greater petrosal will be joined by deep petrosal. Deep petrosal is sympathetic nerve from cervical ganglion. The two of them will form the Vidian nerve, which is also called the nerve of pterygoid canal. And synapsing will now occur at the pterygopalatine ganglion. From the ganglion, postganglionic nerve follows the lacrimal branch of ophthalmic nerve to get to the lacrimal gland, and that's the innervation of the lacrimal gland. So you have preganglionic fibers from the nervus intermedius or facial. They pass through geniculate ganglion without synapsing. Then the facial nerve will give greater petrosal nerve, which will be joined by deep petrosal, that is sympathetic from superior cervical ganglion. The two will form Vidian nerve or nerve to pterygoid canal that will synapse in the pterygopalatine ganglion, from which postganglionic fibers will hitchhike on lacrimal branch of ophthalmic nerve to get to the lacrimal gland. Then we have extraocular muscles of the orbit. We have the levator palpebra superioris, the four recti, superior, inferior, medial, and lateral rectus, and you have two obliques, superior and inferior. And these muscles are able to move the eye. So these are the functions of each of the muscles. Okay, levator palpebra superioris will elevate the superior eyelid, and then these other ones, that's the action of the muscles. Then these are the arteries to the orbit, ophthalmic artery, and the veins, ophthalmic veins that communicate with the cavernous sinus, and also have the central vein of the retina. Cranial nerve 2, 3, 4, and 6 innervate the orbit. All